Power lines are everywhere, crisscrossing neighborhoods, cities, and even mountain ranges. In all of these environments, Xcel Energy's Vegetation Management Group is charged with minimizing the electric service reliability threat that vegetation can pose to the 17,000 miles of electric transmission and 72,000 miles of electric distribution rights-of-way across 8 states.
We've really been so proactive in going after this since we first started seeing the threat, and have really stayed after it very aggressively from that point on.
Xcel Energy started to explore the technology known as light detection and ranging, or LiDAR, to assist in vegetation management.
LiDAR is, you can think about it like a laser rangefinder on steroids. Many people are familiar with laser rangefinders. You point a laser rangefinder at an object and it gives you a measurement, a very precise measurement to that object.
Xcel Energy worked with Geodigital to explore ways that LiDAR could pinpoint trees and other vegetation that might be too close to Xcel Energy's facilities.
This is one of those remarkable things if you sort of step back and realize just how powerful this technology is. The laser rangefinders are put in the helicopter. We're flying down the line at about 300 feet above ground with a laser scanner going down the line, throwing 300,000 to 500,000 pulses per second out. And we're capturing all that data back and timing when the light leaves the helicopter until it hits an object. And everything it hits, it gives us an X, a Y, and a Z coordinate of that object.
The technology could do a fantastic job of accurately determining clearances from vegetation to conductors, and then we could set a threshold distance and say, we want to know about any vegetation that's closer than this distance, and then go out and manage it.
I think you can see across Colorado the fire suppression policies we had for half a century, and then the warmer and drier weather conditions, especially over the last 10 or 15 years. All those things have come together as a perfect storm that really exacerbate the forest health issues we've had.
Unhealthy forests and hot temperatures led to an unprecedented mountain pine beetle epidemic. No bigger than a grain of rice, the mountain pine beetle has devastated more than 4 million acres of forests in Colorado alone.
The impacts to electric utility infrastructure, really you can boil it down into 2 categories. One is having a dead tree fall and strike a conductor and cause an outage, obviously, but also spark, maybe catch on fire and be the ignition point for a wildfire. The other category of threat is damage to the infrastructure itself. So no matter where a wildfire might start, having it burn through transmission right away in particular, or distribution for that matter, and damage or destroy facilities is a real concern. And you can only imagine how difficult and challenging it would be to replace structures in terrain like this.
Using cameras with near-infrared filters, Geodigital proved that it could scan hundreds of miles of lines and pinpoint individual trees that were healthy, declining, or dead. And it could also reveal which of those trees posed a threat to Xcel Energy's assets.
Without LiDAR, we're sending guys out onto the right-of-way, and they're eyeballing, trying to determine what heights are, what clearances are, and trying to identify which trees could possibly be a threat. And obviously they're going to be very conservative. They're going to go after any tree they think has any chance. The advantage to LiDAR is we can precisely identify in a surgical fashion which trees truly are a threat, go after those, and leave the other ones alone, which has saved us millions in terms of managing this hazard tree threat.
LiDAR data points out problem trees and specific areas to be managed. But it is another challenge entirely to get that information into the hands of the teams in the forests, the people who hike in with chainsaws and cut down or mitigate the hazards. To understand what it takes to pinpoint a hazard tree in the middle of the forest, and then to tell a ground worker exactly where to find it, imagine layering map on top of map on top of map.
I provide a data set, a background data set of all of our facilities. Then the LiDAR flights happen, they process the data for the type of information that we're looking for. We take that data and lay it over the top of those maps. So now we have a way of looking at our facilities along with the LiDAR data, along with maybe the mountain pine beetle data, so that we can get a really good picture when we're in the field of what actually is being impacted and what we need to mitigate at that point.
Then, of course, you have to give that data to the ground crew in a way that's practical and intuitive.
This tablet right here is the key to our entire GIS initiative. Each tablet utilizes GPS and wireless communication technologies and essentially allows field personnel to send near real-time data from the field to a manager.
In 2011, ground crews started using the tablets in the field to identify and remove hazard trees, and the results have been excellent. Approximately 250,000 hazard trees mitigated on both distribution and transmission lines since 2008.
One of the immediately noticeable advantages that the system provided was the ability for crews to know where they were when they were standing on the ground.
Encouraged with the results, and with crews furiously working on threats created by the mountain pine beetle and unhealthy forests, the vegetation management team started looking at the next opportunity to protect transmission structures from wildfire.
The first unknown that I had was, what are the heat thresholds for the infrastructure? How much heat can they stand? We've got the various different structures, which are either H-braces, and they can be wood, steel, or aluminum, and various different steel lattice towers, aluminum lattice towers, wood, and then the conductor, and that's the wire that carries the electricity.
Once the team understood an approximation of how much heat each type of structure could withstand, they had to determine an estimate of how much flammable material could be tolerated near the transmission structures on the forest floor and in the surrounding trees. In a wildfire, those materials would create different levels of heat.
The idea that we had was, let's ask this fire scientist to go and look at about 70 randomly selected structures across the mountain pine beetle epidemic area, and have him use traditional methods to quantify the fuel loading on the ground, the surface fuels, as well as calculate crown closure from the forest adjacent to those structures. And then the thought was, in parallel with that, we would have the folks from Geodigital try to quantify those same conditions remotely. What our fire scientists said was on the ground in terms of fuel load, tons per acre, and the density of trees adjacent to those structures was almost 90% of the time the same as the results that they were getting from running algorithms across that same LiDAR data set. So that got us pretty excited that, again, we could essentially push a button and calculate the critical factors that we needed to understand in order to attempt to protect transmission facilities from a passing wildfire.
The LiDAR technology just gives a tremendous amount of data that never was available before. And the big thing that it really delivers to us that we didn't have before is the opportunity to have essentially a 3D geospatial model of our facilities and their surroundings.
I'm impressed that Xcel has got the forward-looking vision to say, we really got a problem here, and maybe we ought to start doing something about it. And it's setting a trend that I think will be taken up by many other utilities.
Today, the vegetation management team keeps pushing technology to its limits, protecting Xcel Energy's assets and improving public safety.
This actually does matter. It matters that we're able to do a better job of managing, managing the risks of fire in these environments that we operate in.
We're looking at issues that haven't even happened yet in an effort to mitigate them before they do. And it's hard to find other utilities that are really acting in that kind of a forward-thinking way.
Xcel Energy takes its responsibility to our community very seriously. This revolution in vegetation management illustrates our persistent drive to use cutting-edge technologies, entrepreneurial partnerships, and hard work to deliver more reliable service and to work toward a safer environment for everyone in the regions that we serve.